In this video, we're going to look at two examples solving absolute value inequalities. In the first example, we're going to first isolate for 2x plus 3 inside absolute value signs. In order to do that, we need to add 7 to both sides, giving us 15 on the right-hand side. Now, to proceed solving this absolute value inequality, we need to remind ourselves of what it means to have an absolute value of a number. Essentially, it means that we're looking at the distance from that number to 0. Let's take a look, for example, if we take absolute value of 5. What that means, we're looking at what is the distance from 5 to 0. And of course, we can see that it's 5 units away. So the absolute value of 5 is just going to be positive 5. Now, if we take absolute value of a negative number, let's say negative 5, for example, we're still 5 units away from negative 5. So absolute value of negative 5 is still positive 5. But we can think of it the way absolute value function does this. It multiplies a negative number by a negative to make it positive. So we'll get positive 5. So in general, when you take absolute value of any number, let's say x, we can write this as a piecewise function. We can say that it's going to stay the same if it's already positive, or even if it's 0. So if it's already positive, it stays the same. But if it's negative, we need to make it positive by multiplying it by negative. So if we come back to our example, we have two cases to consider. 2x plus 3 could be positive, which means it doesn't change, it stays the same. So we are solving then 2x plus 3 is less than or equal to 15. Or the second case, if 2x plus 3 is negative, what happens then? Well, absolute value will multiply it by negative to make it positive. And so we're solving negative of the quantity 2x plus 3 is less than or equal to 15. Now, if we isolate for 2x plus 3 in the second case, we would need to divide by negative 1. And divided by negative flips the inequality sign, meaning that we are looking at 2x plus 3 has to be greater than or equal to negative 15. Now we can combine these into the inequality, which says that 2x plus 3 is between the negative number and a positive number, so between negative 15 and positive 15. This could also be seen if we looked back at the definition of the absolute value. Saying that 2x plus 3 in absolute value is less than or equal to 15, we're saying that 2x plus 3 is less than or equal to 15 units away from 0. So I could be 15 units away from 0, 15 or less, of course, on either side of 0. We could be anywhere between negative 15 and positive 15. And so we can proceed solving this by trying to isolate for x in the middle, meaning we need to subtract 3 from the middle. But whatever we do to the middle of this inequality, we need to do it to other sides of the inequality as well so that it holds true. So that means 2x has to be between negative 18 and 12. Next, we would have to divide by 2 in order to get x by itself. And whatever we do to the middle again, we do it to the other side as well. And dividing by a positive number doesn't change the inequality signs, so they stay the same. So we're saying that dividing negative 18 by 2 is negative 9. And 12 divided by 2 is going to be 6. So our solution is x is between including negative 9 and 6. To put this in an interval notation, we can say that x is an element of closed interval between negative 9 and 6. We use square brackets to show that negative 9 and 6 are included. Let's take a look at the second example. Again, in this one, we have to isolate for absolute value quantity, meaning that we need to subtract 1 from both sides, giving us the absolute value of 8 minus 3x has to be greater than 4. Just like before, if we consider two cases, 8 minus 3x could be positive. So that means it would stay the same, and we're solving 8 minus 3x is greater than 4. Or we could have a second case if 8 minus 3x is negative. But that means we would need to make it positive by multiplying it by negative. And that is also greater than 4. But if we isolate for 8 minus 3x, we need to divide by -1 in order to get 8 minus 3x by itself, which means we would have to flip the inequality sign, and we're saying that it's less than -4. We could also arrive to this by looking at the number line, saying that 8 minus 3x in absolute value is greater than 4. We're saying that 8 minus 3x is more than 4 units away from 0. So we could be more than 4 units away from 0 on either side of 0. So it could be less than -4 or more than 4. 8 minus 3x could be anywhere not including -4 and 4, and that would mean it will be more than 4 units away from 0. So if we have an absolute value quantity greater than a number, we can just take it to be more than the positive of that number or less than the negative of that number, and then proceed solving each individually. So let's take a look at the first one. To solve for x, we would need to subtract 8 from both sides, which will give us -3x is more than -4. Now dividing by -3 to get x by itself means, again, we need to flip the inequality sign because we're dividing by negative. So we'll get +4/3, and so x is less than 4/3. Let's solve the second one. Second case gives us -3x. Subtracting 8 from both sides will give us -12. And now dividing by -3 both sides, flipping the inequality sign, we'll get x is greater than 4. Now to put this in interval notation, it may be helpful to draw a number line to see what's going on. So let's say this is my 0. Here somewhere is 4/3, and let's say this is 4. So my inequality solution says that x could be less than 4/3, or it could be more than 4. So when we're saying this in the interval notation, we're saying that x could be from -infinity to 4/3, and we use round bracket to indicate 4/3 is not included since there's no equal sign, or this union symbol is another way of saying or, from 4 to infinity. So those are the two examples of one way of solving inequalities with absolute value.